Hello students, today in your algebra class you're going to be working on scientific notation. So at the end of this lesson you should be able to put numbers in scientific notation or standard notation. So here are a couple rules that I would like for you to pause the screen and write down these notes. So just to explain them, in order for something to be in scientific notation, the number itself must be greater than or equal to 1, it must be less than 10, and will always have the suffix times 10 to the a, where a is some number. Now, a negative exponent means you move the decimal point to the left, and a positive exponent means you move the decimal to the right. So let's take a look at this example and put this into scientific notation. It is 9,040,000,000. Now, in order for this to work, we need to decide where to put the decimal point. So we're going to try putting the decimal point in a couple different places just to show you when it would be okay and when it would not be okay. So if we were to put the decimal point right here in front of the 9, you'll notice that our number now is 0.904 with all these zeros. And unfortunately, that number is not greater than or equal to 1. Therefore, we cannot use it. So I'm going to erase that point. And we're going to try a different place. We're going to put it after the first zero, and it gives us 90.4 with all the zeros. Notice again, this number is greater than 10. So we're going to put our decimal point here, right after the 9, and that gives us a number of 9.04 with all these extra zeros. So this number itself gives us the base for what our scientific notation number would look like. I believe bullet point number 3 says it always has times 10 to the some power. So that's the part we have to figure out now. So to figure out what that number would be, we have to decide how many decimal places we needed to move this thing and which direction, left or right. So this is very important. We're going to start at where our decimal point is, the red point, and where it was originally. And where it was originally, it was here at the end in blue. So we, starting at the red, move our decimal point to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we moved it 9 places to the right. Therefore, our decimal, or our exponent, should be to the 9th power. Okay, now let's try it again for example 2. Number 2, we need to figure out where to put our decimal point. So hopefully you know that we want to put it after the 3 because 3.25 or 3 and 25 hundredths is greater than or equal to 1 and still less than 10. So we're going to write down our number, 3 and 25 hundredths times 10 to the something power. So now we're going to start at our new point, which is at 3.25, and move it to our original, which happens to be at the very beginning, which again we'll put in blue just to make sure it's clear. So from our new point in red, we're going to move it to the left. 1, 2, 3. So we moved it 3 places, and remember, because we moved it to the left, that 3 should be a negative 3. Okay, let's try one more just to be extra clear. So 8,040,000 is our number. To put that into scientific notation, we need to put the decimal point right after the 8, which gives us 8 and 4 hundredths, or 8.04, times 10 to the something power. Now again, we need to move it from our new point to where it was originally, which is at the end. So 1, 2, 3, 4, 5, 6. So let's try that one more time because I made that look a little funky. So 1, 2, 3, 4, 5, 6. So I moved it 6 places to the right. So that's positive 6 because it's to the right. Example 3 is now asking you to put things in standard notation. So standard notation is when we take something in scientific notation and just break it down so that it's one larger number with no exponents. So if we look at example 3, it's saying that we have 4.63 times 10 to the 4th, and because it's times 10 to the 4th, it means we move the decimal point 4 times, and because it's positive, we move it to the right. So I'm going to rewrite our original number and add some zeros, just to make sure you see how it changed. So now we have this number, and we're going to move the decimal point. So it says move the decimal point 4 places to the right. So 1, 2, 3, 4. So your final answer would be 4, 6, 3 with 2 extra zeros. So that's standard notation for example 3. Example 4, notice we have 2.4367 times 10 to the negative 6th. That means we need to take that number and move the decimal place 6 places, and because it's negative, we move it to the left. So we're not going to do the extra zeros, we're just going to make sure we put these extra indents. So 6 places to the left. 1, 2, 3, 4, 5, 6, and that's where our decimal point would be. So in between where we have these little ditches, if you will, we're going to put zeros, because that's what that little hole is for. We're supposed to fill it in. So we are going to have 0.0, 0, 0, 0, 0, 2, 4, 3, 6, 7. So notice that there were 1, 2, 3, 4, 5 holes, so we had to put in 5 zeros. So to clean this up, our number would now be 5 zeros, 2, 4, 3, 6, 7. This is what it would look like in standard notation. The last one, where they're asking us to multiply, then put in standard notation. So first of all, we're going to do the easy part. 2 times 4 is 8 times 10 to the 11th power. And this is telling us that we need to move the decimal place 11 places. And because it's positive, we need to move it to the right. So we're going to start with our number, which is 8, with the decimal point obviously at the end. And we're going to move the decimal place 11 places to the right. So it's moving once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 holes. So that means there's going to be 11 extra zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And put our commas in the appropriate spots. So we have 800 billion as our number. And that's the reason why we use scientific notation, because writing 800 billion over and over and over again becomes daunting. That's why we do scientific notation, because it simplifies the numbers and makes them a little bit more digestible, if you will. So now it's your turn. I want you to try solving these 3 problems and putting them in your notes. and tomorrow when we take a look at it, we'll do some practice. That's all for now. See you guys next time.